Good evening students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the question number 4 of exercise 10.6 of class 9 chapter 10 NCERT circles. Okay. So let us start with the question number 4. The question number 4 says, let the vertex of an angle ABC be located outside a circle and let the sides of the angle intersect equal chords AD and CE with the circle. So we have to prove it. Prove that angle ABC is equal to half the difference of the angles subtended by the chords AC and DE at the center. Okay, so first of all in the question, let us understand the question. In the question it is being given that the vertex of an angle ABC be located outside a circle. So I have made a triangle ABC and the vertex of this angle is located outside the circle. So this is the circle and the vertex is located outside it. Okay. Next it is saying that let the sides of the angle intersect equal chords AD and CE. Okay. So AD and CE are intersected by equal chords. So AD and CE are intersected by equal chords and the chords AD and CE are being equal. Okay. Then we have to prove that angle ABC is equal to the difference of the angles subtended by the chords AC and DE. So by the chord AC is this. Let us join A and C. So chord AC is this. So AC subtends an angle AOC. Okay. AC chord subtends an angle AOC and AOC is, I have assumed it to be X. Okay, I have assumed to be X and the angle subtended by the chord DE. Angle subtended by the chord DE is DOE and I have assumed that angle to be Y. So I have to prove that my angle ABC, this angle is equal to half of the difference of the angles subtended by the chords. So half of the angle AOC minus angle DOE. This forms my difference. So I have to prove that angle ABC should be half of this difference. Okay. So I have assumed angle AOC to be X. So I will substitute my value X and DOE to be Y. So I have to prove that angle ABC is equal to angle half X minus Y. Okay. So this was about the question. This thing we have to prove it. This is an important question and it came out to be a doubt question. So we are solving it in detail over here. Okay. So it is given that AD is equal to CE. AD because they have given chords to be equal and construction I have made this chord again. It is forming a chord AC and D. I have joined it. Okay. So this is all about the question. Now let us start solving the question. Okay. So here I have assumed to be AOC to be X, DOE to be Y and my AOD and angle COE will be equal. The angles will be equal because they are subtended by the equal chords. The angle subtended by the equal chords AD and E is equal to CE. AD and CE are equal. So the angles subtended by the chords, equal chords at the center are equal. This is we have already studied in the theorem. Okay. So this angle and this angle becomes equal. This angle and this angle becomes equal. So this is also Z and this is also Z. I have assumed to be Z. Okay. Now we know that the sum of all the angles at a point is equal to 360. So let us start a question with this concept. So angle AOC plus angle DOE plus angle AOD plus angle COE, it is equal to 360. Okay. So X plus Y plus Z plus Z is equals to 360. Okay. So from here I can find out the value of Z. So my Z will be equal to 360 minus X plus Y upon 2. Okay. And that comes out to be equal to, therefore Z is equal to 90 minus, sorry, 180. 180 minus x plus y upon 2. Let us mark it as equation number 1. Okay. We will be marking all the equations, and accordingly we will be proving what is given. We have to prove ABC. So accordingly we will be proving the angle ABC. Okay. So now we will be taking triangle AOD. Okay. Now we will be taking triangle AOD. So in triangle, OD and OA are equal because it forms the radius of the circle. O is the center. Okay, so OA is equal to OD. OA is equal to OD. So when the OA is equal to OD in the triangle, this angle will be equal to this angle. So angle OAD will be equal to angle ODA. Okay, so angle ODA will be equal to angle OAD. Okay, and in a triangle the sum of all the angles is equal to 180 degrees. So let us mark it. So angle OAD plus angle ODA plus angle AOD is equal to 180 degrees. Okay, AOD, we already know the value of AOD is Z. Okay, so let us find out the angle value. Angle OAD will be equal to angle ODA, which will be equal to 180 minus Z upon 2. Okay, and it will come out to be 90 minus Z by 2. It will come out to be 90 minus Z by 2. Okay, and it will come out to be 90 minus Z by 2. So let us mark it as equation number 2. Similarly, we can find out Similarly, we can find out it for triangle COE. In the triangle COE also, OC is equal to OE, and so this angle will be equal to this angle. Okay, so when the angle will be equal, we can easily find out the value of OCE and OEC. So let us find out. Now taking triangle COE. So in triangle COE, OC will be equal to OE. OC will be equal to OE because it forms the radius of the circle. Okay, so angle OCE plus angle OEC plus angle COE will be equal to 180 degrees. Okay, so OCE and EC are equal. So angle OCE is equal to angle OEC. Okay, because my OC and OE are equal, it forms the radius. It forms the radius of the circle. Here also you can write it forms the radius of the circle. Okay, now so from here we can get the value of angle OCE, which will be equal to angle OEC, which will be equal to angle OEC, which will be equal to 180 minus Z by 2. 180 minus Z by 2, which comes out to be 90 minus Z by 2. Which comes out to be 90 minus Z by 2. Let us mark this equation as number 3. Let us mark this equation as number 3. Okay. Now, these two triangles are my over. Now, let us again take triangle AOD. In triangle AOD, angle ODB forms the external angle, and the external angle is equal to the sum of two opposite interior angles. So angle OAD will be OD DB, sorry, ODB. Angle ODB, angle ODB will be equal to sum of angle OAD and angle AOD, because it forms the exterior angle, and the sum exterior angle is equal to sum of two opposite interior angles. So opposite angles are this, and so this angle will be equal to sum of this angle. This whole angle will be equal to sum of this both. Okay, so angle ODB will be equal to angle OAD. This we have already learned in the previous chapters concept. OAD plus angle AOD. Okay, so angle ODB will be equal to, we have already found out angle OAD. So OAD is equal to 90 minus Z by 2. Okay, so we can put here the value 90 minus Z by 2, and angle AOD we have assumed already in the beginning that it is equal to Z. It is equal to Z. So ultimately my value ODB comes out to be 90 plus, after solving it, after taking the LCM, I will be getting minus Z plus 2Z. So it will give me 90 plus Z by 2. 90 plus Z by 2. So let us mark this equation as number 4. Okay. Now similarly, taking the triangle COE, in triangle COE, angle ODB was exterior angle. Okay. So similarly in triangle COE, angle OEB was exterior. You can write it as is because it is already exterior. Is exterior angle. Okay, so angle OEB will also be equal to, here also the same concept will be applying. Angle OEB will be equal to sum of opposite interior angles. So opposite interior angles are angle COE and angle OCE. Okay, so let us mark it. So let us write down angle OEB is equal to angle OCE plus angle COE. COE already we have assumed in the beginning that it is equal to Z, and angle OCE we have found out over here it is equal to 90 minus Z by 2. So from equation 3 we can write the value of angle OCE. So it will come out to be 90 minus Z by 2 plus angle COE is we have already been assumed to be Z. Okay, so angle OEB will be equal to 90 plus Z by 2. So this is, let us mark this equation to be equation number 5. Okay, we have reached till equation number 5. Now taking the triangle EOD, taking the triangle in triangle EOD, in triangle EOD, OD and OE are the radius, so they are again equal, and so we can say angle ODE is equal to angle OED. Okay, so here OD is equal to OE is equal to radius. Okay, so my both the angles are equal. The triangle forms an isosceles triangle, so my both the angles are equal over here. So I can write that angle ODE is equal to angle OED. Okay, and the sum of angles of a triangle is equal to 180 degrees. So I can easily write over here plus angle DOE is equal to 180 degrees. So ODE and OED. Okay, so I can find here from here angle ODE and OED. So angle OED twice angle OED and DOE I have already assumed to be Y. Okay, so let us mark it as Y equals to 180 degrees. So from here I get angle OED, which is equal to my angle ODE will be equal to 180 minus Y upon 2, and that comes out to be 90 minus Y by 2. Okay, let us mark it as equation number 6. Let us mark it as equation number 6. Okay, now I have completed this triangle. Now my angle OEB is comprised of two angles. It is comprised of two angles. If I will add angle OED and angle DEB, then I will be getting my angle OEB. Okay, then I will be getting my angle, this whole angle. This whole angle is comprised of angle OED and angle DEB. Similarly, angle ODB is comprised of two angles, angle ODE and angle EDB. Then I'll be writing this thing only. I'll be writing the sum of these two angles is equal to angle OEB. Now let us write it down, and we will be finding out the value of angle DEB. We will be finding out the value of angle DEB. Okay, so angle OEB, angle OEB is equal to sum of angle OED plus angle DEB. So ultimately I'll be getting this angle. When I'll be getting this angle, then in the later steps I'll be finding out this angle, and then we will be getting all the angles of the triangle DEB, and we can equate it to 180 degrees, and we can easily find out the angle DBE, which is my same ABC. Okay, my DBE, either you say DEB, either you say DBE or you say ABC. It is one and the same thing. Either I can say my angle DBE or I can say my angle ABC. Both the things are same. So from this small triangle I can easily find out my value. Okay, so let us first find out the value of angle DEB. Angle DEB, this value. OEB we have already found out from equation number 5. And OED is equal to ODE. So ODED we can place from 6. So we can easily write from equation 5 and 6. So we can substitute the value of OEB. OEB value is 90 plus Z by 2. 90 plus Z by 2, which is equal to OED. OED value is 90 minus Y by 2. 90 minus Y by 2, and plus this angle I have to find it out. Angle DEB I am supposed to find it out from here. Okay, so this 90 and this 90 gets cancelled. So ultimately angle DEB will be equal to angle DEB will be equal to how much? Z by 2, and this is minus sign over here. So when it will go on that side, it will become positive. The sign will be converted to positive sign. So it will become positive. So my angle DEB will be coming out to be Z by 2 plus Y by 2. Z by 2 plus Y by 2. Okay, it will be coming out this. I can combine it and I can get Z plus Y. Okay, or Y plus Z. Okay, similarly I can find out my angle EDB. By saying that angle ODB is equal to angle ODB is equal to sum of angles ODE and angle EDB. Angle EDB. Okay, so ODB, already we have found out the value in equation number 4, and angle ODE is equal to angle OED, and we have already found out the value from equation number 6. So from 4 and 6 we can substitute the values of the angles. So angle ODB is equal to 90 plus Z by 2, and it is equal to ODE. ODE value came out to be 90 minus Y by 2. 90 minus Y by 2 plus angle EDB. So therefore angle, yes, we have left out to mark the equation over here. Let us mark this equation to be 7. Okay. So angle EDB, has came out to be, again this gets cancelled, came out to be 1 by 2 Z plus Y. Same as we have found out angle DEB, so same value comes out to be angle EDB. Okay, let us mark it as equation number 8. Okay, so now we have got all the 3 angles of this, we have got 2 angles of this triangle, and this angle we are supposed to be finding out. So now taking the triangle BED, taking triangle BED. Okay, taking triangle BED. So when we are taking the triangle BED, angle BED plus angle EDB plus angle DEB is equal to 180 degrees. Okay, is equal to 180 degrees. The sum of all the angles in a triangle is equal to 180 degrees. So we need to find angle BED. It will be this angle will be equal to DBE. We need to find the angle DBE. Okay, and DBE will be only will be same as my angle ABC. Okay, so EDB we have already found out the value of EDB, which is supposed to be 1 upon 2 Z plus Y. Okay, Z plus Y, and DEB also we have found out. That is also equal to 1 upon 2 Z plus Y, and it is equal to 180 degrees. So therefore angle DBE comes out to be 180 minus 1 upon 2 Z plus Y minus 1 upon 2 Z plus Y. These both are same, so half Z plus Y and half Z plus Y will get added with a negative sign, so that will become 2 upon 2. So it will become 180 minus 2 upon 2 Z plus Y. Okay, and this gets cancelled out over here. So my angle DBE comes out to be this. Now here I am left with Z, but I need to find my proof. My proof is in the terms of X. I have to prove that angle ABC, or rather I can write over here angle ABC is nothing but it is equal to angle EBD or DBE. Okay, so my angle ABC is nothing but it is equal to my angle DBE. Okay, so I need to find in terms of X. Okay, so these values are substituted from equation 7 and 8, EDB and DEB. So from equation 7 and 8. Okay. And now I will substitute the value of z, because my DBE is, came out to be 180 minus z minus y. Okay, so now I'll substitute the value of 1. I have found out the value of z in the equation number 1. So from 1, my value of z is equal to 180 minus x plus y by 2. So the whole value I am going to substitute over here. Okay, so let us substitute it. So we'll be getting 180 minus 180 degrees plus x plus y by 2. X plus y by 2. Okay, so this gets cancelled out. This gets cancelled out. And ultimately, I'm left over here with x by 2 and minus y by 2, because when we will be taking the LCM over here, we will be getting 2 minus 2y plus y, and minus 2y plus y is equal to minus y. Okay, so we will be left over here with angle DBE will be equal to x by 2 plus 2 LCM I am taking y minus 2y. So ultimately we are left with 1 upon 2 x minus y. So therefore angle DBE comes out to be 1 upon 2 x minus y. Okay, and this thing only we need to prove. This thing only we were needed to prove. Hence proved. Okay, so what we did, we firstly we assumed it, we applied the concepts of theorem and circles and also the concepts of triangle. Okay, so firstly we assumed. Let us understand once again, this question is very important from the exam point of view, and it was a doubt question of many of the students. Okay, so firstly we assumed it, all the values, angle AOC and angle DOE and angle AOD and angle COE. Now the students some of the students said, why not ma'am assume it to be a different variable, but we are assuming it to be equal because my equal chords AD and C are given equal. So equal chords when they subtend angle at the center, they are equal. So I have assumed it to be Z, and I have assumed angle AOC to be equal to angle DOE, which is X and Y. Okay, now the sum of all the angles around the point is equal to 360 degrees. We have been studying this concept from 6th and 7th. Okay, so x plus y plus z will be equal to 360 degrees. So from here I have found out the value of z. Okay, now in the next step, we have taken the triangles AOD and triangle COE. So angle AOD plus angle OAD plus angle ODA will be equal to 180 degrees, because it forms a triangle, and OA is equal to OD, it is equal to radius. So angle OAD, the value will come out to be equal to 90 minus z by 2. So I'll be marking this equation as 2. We can mark it as equation as 2. Then taking the triangle COE, over here. Then over here also OC and OE are equal to radius. So again we can find out the value of OCE and angle OEC. Okay, then again we are taking the triangle AOD, but we are applying the concept of exterior angle. The exterior angle is equal to the sum of opposite interior angles. So angle ODB will be equal to angle OAD and angle AOD, because these two angles are opposite. Similarly, in the triangle COE, we can find out the angle OEB, which is equal to opposite interior angles. So opposite interior angles are OCE and angle COE. Okay, then after finding out the values of OCE and ODB, we are dealing with the concept that triangle DOE is also isosceles triangle EOD, DOE, you can say EOD or you can say also say DOE. So this triangle is isosceles again. Why? Because OD and OE are equal to radius R. Okay. Then again we are applying the concept of the triangle, that the sum of all the angles of the triangle is equal to 180 degrees. So angle OED is equal to angle ODE, which is equal to 90 minus y by 2. Similarly, from here I can find out my values OEB and is equal to angle OED plus angle DEB. So I already know that DOE, my value is equal to y because I have assumed it in the beginning itself, and OED I can find it out from here. Okay, so I have already found out and angle DEB from here, and similarly to taking the triangle this, I have found out the value EDB from here. Okay, then this triangle, small triangle, the sum of all the angles of the triangle are equal to 180 degrees. So angle DEB plus angle EDB plus angle DBE is equal to 180 degrees again. So angle DBE I have found out from there, and my DAB is nothing but it is equal to angle ABC, and that ABC is supposed to be equal to 1 upon 2 x minus y, because x is the angle subtended by the chord AC. X is the angle subtended by the chord AC. This we can write over here. This is nothing but the angle subtended by AC. Angle subtended by AC. Okay, this, and y is the angle subtended by DE. Angle subtended by DE. Okay, by DE. So x minus y, this only I have to prove. So thank you. In this way only we have to do rest of the questions. Thank you once again, and so please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.